Okay, good morning everyone. Welcome to another free online GCSE Maths lesson with Pearson in collaboration with LGfL. We'll be starting in a minute or two. Okay, so welcome all of you, and we'll get going at 11 o'clock, which I make it 10:58, so a minute or so. Okay, I'll make it 11 o'clock, so well, that doesn't say that on my time on my up in the top right hand corner of my computer. I'm going to make a start. So, good morning everyone, hope you're all well. I know we're getting towards the summer holidays now, but we'll keep going, and today we're going to cover Pythagoras Theorem in 2D. And I'll just go through the housekeeping issues. So it's Mr. Smart here again hosting today's session, and we're trying to make the maths a bit more relevant, a bit more fun, a bit more real life if you like, but still whilst equipping you for your exams and beyond. So today's session, you'll need pen, pencil, paper. You'll definitely need your calculator today, I would say, so please make sure you've got one to hand, and round all answers to 2 decimal places unless otherwise stated. So until we get to the exam questions at the end, you'll pretty much be working to 2 decimal places all the way through, folks. Okay, so today's objective: understand, recall and use Pythagoras theorem in 2D, including leaving answers in surd form and being able to justify if a triangle is right angled or not. And obviously a squared plus b squared equals c squared, where c is the hypotenuse, is Pythagoras theorem, and we're going to use that all the way through, but we're going to use it and try and apply it to some real life situations. How does it work? Anything in blue basically is for you to have a go at. Anything in purple is something a bit trickier or just requires you to think in a slightly different way. And if we have a yellow box over something, that is just basically covering up a solution. So sometimes the yellow boxes may have answer written on them, but if you see a yellow box, it's covering a solution. And just to give you the idea, if we was to substitute x equals 3 into the following expressions as I've asked up there, and then to reveal, you'd actually get the answers to those 2 questions. So we'd have the answer 4 times 3 is 12, 12 subtract 16 is negative 4, that's for the first one, and x squared is 9 in this case, 3 times 9 is 27, 27 add 3 is 30. So underneath that yellow box was the answer to these 2 questions up here. So let's have a look at how we're going to do this today. We're actually going to look at it in real life. And this resource was created, with the Coast Guard. And the Coast Guard are the people that go out to rescue people at sea. Not just at sea, but they're the people that you'd call if your boat was sinking, basically, or if you had unluckily fallen down somewhere near a mountain or a cliff, these would be the people that would come out and help you. And we're going to use Pythagoras theorem to help us. So let's just paint a picture. We're not going to do any maths for a while. I just want to get you in the right frame of mind for this type of activity. First of all, we've got a scale up here. You won't be able to see this on your screen, so I've given you the measurements. But the idea is, when I do this in class with students, is that they draw their own scales. 1 nautical mile is equal to 2 little squares. A nautical mile is just a measurement that we use when we're in the air or at sea, and it's slightly longer than a land mile. So a nautical mile is just basically a length. And what I'm going to say to you here is how, for instance, if this ship here, this blue ship, was sinking, and we was going to send this red lifeboat B to rescue, how would we calculate the shortest distance? Some of you say we'll just measure it, but in real terms, how would that be measured? Well, we'd probably draw a line horizontal to here, then a vertical line, okay, and then we can see there that the shortest distance would be given by the diagonal. Now what we've got there is where the horizontals met the vertical, we have created a right angle, okay? But if you think about this practically, you might decide that you want to send the helicopter. Why might you decide to send the helicopter? Surely you weren't not going to send the helicopter, it's got further to go. But some of you will be thinking in your mind already, well, yes, it may have further to go, but it goes faster. So that may be what I would send. So again, you may be making lots and lots of calculations in a very short period of time and then trying to make the best decision. Now, the computers and all of the calculators and all of the things you have to hand will help you make the calculations, but ultimately humans will still make the decisions at the moment. So all of this information has to be applied and you really have to use it. So for instance, if we look at this one here, it could be that ship B was sinking. And you're going to send the helicopter. How would you calculate? And don't forget as well, it's not just the distance that you'd need to calculate. You may need to calculate the bearing as well. So how would you calculate the angle? Well, you'd use trigonometry. That's a future session. Okay? But you can see here, you could create a right angle quite nice and easily. You could say, okay, and then join it up, and so on. And you can see here what I'm trying to do. I'm just showing you. The idea is if you was doing this in class, you would actually be drawing these triangles yourselves. Okay? To create the right angles and then investigate further. So let's move on to one that I've sort of prepared. And this is the first one here. Now, I've put the measurements on. And this is Lifeboat B, which is down here. And we're going to send Lifeboat B to save the people on this sinking ship. There's a red target there. And right in the middle of that target was where the ship is sinking. So we're going to have to work out this distance. Now, the first distance is given by the length 5.5 and 4. And that creates a right angle. So we're going to use Pythagoras. And most of you will be familiar with Pythagoras Theorem, but obviously it's a theorem where we put the shorter sides, we substitute the lengths of the shorter sides in this case 5.5 and 4. We square both of them, so it's 5.5 squared plus 4 squared. And that's going to be equal to the longer side, what we call the hypotenuse squared. And that's what we're interested in calculating here. And if I reveal this, hopefully you'll be able to see clearly that that's exactly what I've done. So I've done 5.5 squared, add 4 squared, and that's equal to c squared. So c squared is equal to 46.25 in this case. And the inverse of squaring something is to square root. So if we square root 46.25, we're going to get 6.80 to 2 decimal places. So that's what this length actually here equals. It equals 6.80 nautical miles. Okay, but clearly the lifeboat hasn't got there yet. It's still got to travel this distance to get to the sinking ship. So how would we do that? Well, fortunately for you, I've actually put the numbers on here. So we're going to focus on this bit here now. So we've got a length here of 2 and a length here of 7. Can you calculate the length of D and then work out the total distance that lifeboat needs to travel? I'll let you have a little think about that. And what I'll also do is I'll write 6.80 there, just so you can remember what that length was from the previous slide. Okay, so have a go at that one yourselves. I'll give you a couple of minutes and then we'll go through it. Like I said, if you just think here, what have I done? The first line, I've substituted in the 2 shorter sides. In this case, it's 2 and 7, so I've got 2 squared, add 7 squared is equal to D squared. And then we can follow the steps through. I'll let you finish it off yourselves, but I'll reveal those answers shortly, just in case you were stuck on that first step. Okay, let's reveal these answers now. So we've got 2 squared plus 7 squared. So 4 plus 49. So d squared is equal to 53. Pretty straightforward. And we know we're going to square root. Now we know the inverse of squaring something is to square root. So d is equal to the square root of 53. So it's going to be 7.28 nautical miles is going to be that length there. So now we're in the process where we can calculate the total distance that the ship will need to travel in order to rescue people, and it's going to be 14.08 nautical miles in total if we add 6.80 and 7.28 together, which is what I've done. What's interesting here though is that we could have selected some slightly different triangles, and that's what I've done here. So Lifeboat B is still going to the same place, nothing's changed except for the triangles that I've drawn. So here I've put 2 different triangles here on, and what's interesting is, will this affect the total distance that the boat needs to travel? Now, think about it logically. You need the boat to get there to rescue the people. This literally could be a matter of life and death. You want the boat to travel the shortest distance because it will get there quicker. So I would like you to have a look at calculating the distances now and see if the total distance this time is less than the total distance on the calculation before. Alright, so have a think about this one here. You can see I've drawn them in. I'm happy to draw on the right angles, even though we know that the vertical and the horizontal meeting will create the right angles, but I'll put them on there just so there's no doubt. Okay, and we're going to calculate this length here, which I can call C if you like, which might help, and we're going to calculate this length here, which is D. Okay, so you're going to need to calculate C and D, add them together, and then see if this distance is shorter or bigger than the calculation before. Don't worry folks, it's exactly the same slide. I've just moved it across to where my answers are, so I'll start revealing them in a few minutes, okay? Okay, let's start taking a look at what's happening. I've calculated C first, by the way, so you might have done it the other way around. You may have calculated D first, okay? But I've calculated C first, and I've done 6 squared add 5 squared equals C squared. So 6 squared is 36, 5 squared is 25, 36 add 25 gives me 61. I've then square rooted 61 to give me my length of C, and that is 7.81 nautical miles to 2 decimal places. So you can see that's C calculated. So that's 7.81 nautical miles. So that bit there is 7.81 nautical miles. And what about D then? Well, D is going to be a similar strategy. Okay, and I'm going to substitute in 6 and 1.5 in this case. So I've got 6 squared add 1.5 squared, which comes out to be 38.25, and then square root 38.25, and that gives me 6.18 nautical miles. And you can see that's going to give me that length there. And you'd expect 6.18 seems plausible because this is a very short distance at the top here of 1.5. So the total is going to be 7.81, add 6.18, and that's going to be 13.99 nautical miles is the distance. If you follow those two triangles, if that was your route, it would be 13.99 nautical miles. And what's interesting now is if we look back at the previous calculation, is this bigger or smaller than the calculation when we looked at the previous one? Well, it was 14.08 nautical miles. So clearly, this most recent calculation was less than the calculation from before. So this was a shorter distance that you've calculated. 13.99 nautical miles is less than 14.08 nautical miles. So this would have been potentially could have saved lives because the boat would have got there. It might have only been a minute quicker, but that might have made all the difference. So that calculation was worth doing. Right, let's move on. Again, slightly different. Same lifeboat, but again, slightly different triangles. Why might I want to stay a little bit further away from this island? If you look here, why practically might I want to keep this distance a bit bigger? Okay, if you think about it, why might you not want to go too close to that island? You know, in real terms, well, there might not be a lot of water. It might be quite shallow, so you might run aground. You know, your boat might hit the seabed. It might actually hit the bottom. So there's other things that you might need to factor into your calculations. But what I'd like you to do is now take a look at this calculation. Again, I've put the numbers on for you and see if this one's going to be shorter or bigger than the one that you calculated previously. Okay, off you go. I wonder if in your mind whether you thought about whether these two triangles, whether it would be a longer distance or a shorter distance just by looking at it. I know I thought it would be a slightly longer distance just by looking at it. So I think obviously I've prepared these resources, so I've got an idea. But I wonder if there's a way of you being able to tell whether you think these triangles are going to give you a longer distance from lifeboat B to where the sinking ship is, or a shorter distance just by looking at it, whether you can tell, or whether you're starting to build a sort of an idea of what's happening. Okay, let's reveal the first. So 5 squared plus 3.5 squared is equal to c squared. I'm doing this length here first, folks, just so that it's clear. And that's going to give me 25, add 12.25, and then that comes out to be 37.25 if we square root it, and then we get 6.10 nautical miles. So the length of C is 6.10 nautical miles. I've put 6.10 because we did say 2 decimal places there. Okay, and now calculating D, which I'm sure some of you have already done, because you're probably putting in your calculator. Once you get good at this, you can just get it in the calculator quickly and get your answers. But I do want you to show you're working out all the time, and we'll get to that and we'll discuss why that's important in the exam question at the end. Okay, but you can see here 2.5 squared plus 7.5 squared is equal to D squared. D squared is then equal to 6.25 plus 56.25, which comes out to be 62.5. Okay, and we square root that, get 7.91 nautical miles, and 7.91 add 6.10 is 14.01. So that is slightly longer than the calculation on the previous slide, because on the previous one it was 13.99. So this using these two triangles was slightly longer distance than the previous calculation. So it just shows you, which route you take can make a difference. Okay, you're going to do more of the thinking now. Hopefully you've got the idea of what's going on. And have a read of this one. Bertrand is a trainee lifeboat dispatcher. He has calculated the length C, so you can clearly see this triangle here that's on there. I'm going to ask you to calculate the length of C, and then I want you to tell me why Bertrand's calculation is not practical. Okay, so this is a nice easy one, but just think about logically. Some people just think, shortest distance. But why is this calculation not practical? What's interesting here as well, you can see that, Lifeboat B looks closer than Lifeboat A. So why would you bother calculating Lifeboat A anyway? Well, Lifeboat A may travel faster. It may go quicker. So even though it's further away, it may get there quicker than Lifeboat B. And similarly, we'll get to the helicopter in a minute. The helicopter could well get there before either of the lifeboats, even though it's further away. So it's not just about the distance, it's also about how quickly you can cover that distance to get to the scene. But there's other factors as well you might want to think about. For instance, the helicopter might only be able to rescue 8 people. If there's 100 people on board that ship that's sinking, you may need to send all the lifeboats and all the helicopters you can find. So there's so many things to think about that, and in future weeks we'll get to this more problem solving, like linking it all together. Today we're just focusing on the Pythagoras Theorem side of it, but there's a lot more simultaneous equations comes into it, distance, time, speed. All of these things will come into it in the next couple of sessions. Alright, let's have a look at this one then and reveal it. Okay, there's the calculation. Nice easy one actually, it comes out with nice easy whole numbers. Okay, so 12 squared plus 9 squared, I'm sure you all know how to do this. 144 add 81, so c squared is equal to 225, so square root of 225 is going to be 15 nautical miles. But I did ask you, why is Bertrand's calculation not practical? Well, it's a boat, and what are we going across here? We're going across land, so there's no way, and that's why we've been doing these other triangles, because we can't go over the land. And a lot of people just look at something as shortest distance. For a helicopter, no problem because it's flying. But for a boat, obviously, it's a bit of an issue. You can't just go over an island. So let's have a look at these Lifeboat A calculations that you can see here. So I want you to calculate the length Lifeboat A has to travel to get from its rescue station to where the sinking ship is. Okay, off you go. I'll give you a few minutes as well on this one. Off you go. I wonder if you think you could have, if you obviously had a sheet of paper, if you had this in front of you as paper, I wonder if you could have calculated a shorter distance by drawing different triangles. I wonder if you could think about that and think, you know what, I could have calculated a shorter distance than the one shown on the screen here. If so, how would you make it a shorter distance from Lifeboat A to where the ship is sinking? What would you have to do? Alright, well let's take a look at this one, calculate it, and maybe in the next slide we can have a look to see if we can come up with a shorter distance than this one. So we've got 11 squared, add 1.5 squared. Just in the interest of consistency, I'm working out C again, which you can clearly see in this case is along here. I'll do it in green actually, just to be consistent. So I'm calculating C there. And that gives me 123.25. When I calculate that, I'm going to square root that. And that's going to give me 11.10 nautical miles. And then we're going to calculate D, which is this length here. And again here, just waiting for my whiteboard there. There we go. 1 squared add 7.5 squared. So my answer is going to be just above 7.5, I suspect, when I actually go through all of this. Square root of 57.25, 7.57. So as I said, just over 7.5. That makes sense. And then if we add up the two totals, we get a total distance of 18.67 nautical miles. But I'm pretty confident that we could have done that in a shorter distance, and I'm sure in your mind you could probably visualize triangles now that could do it in a shorter distance also. So I've drawn them on there, and I just want to show something here. I'm going to do this in real time. What some people may have done, they would say, why have I done this triangle this way round? I could have done it a different orientation. I could have done it here. Okay, I could have gone along to here like so, and then come down from there. Okay, so why did I do the triangle the other way up? Because I still would have got a right angle. It's not come out too clearly there because I'm doing it in real time, but let's just move that down so you can see. It's hard to do. I'm doing this on a tablet, not on an interactive whiteboard, so it's sometimes hard to get it exactly how you want. So there's your right angle. That would be the same triangle. So some people would rather have the triangle that way round. The reason I didn't do it that way round is because then I'd have a 2 here as well and a 7 here. So although it's the same triangle, exactly the same thing, I'd rather not have these twos so close together. So I did the triangle the other way up just to avoid confusion. But you may have drawn your triangles differently. And when I do this in class, the students have to draw their own triangles. They draw the triangles themselves, and then they work through the Pythagoras and the bearings, which requires trigonometry. So there's a lot more to this in practice when you're doing this in an actual classroom to when you're doing it online. So it's slightly different. We've had to adapt it, but the key problem solving thing is the same. But I want you to look up the top in purple. I've said, can you predict if the total distance calculated this time will be greater than or less than the calculation before? Now the calculation before was a distance of 18.67 nautical miles. So can you work out your answer? Before you work out your answer, tell me if you think it's going to be, well, you can't tell me, but think about it in your mind, whether it will be greater than or less than the calculation before. So more to think about, so a little bit more time this time. Okay, let's just reveal C. I know that you will all be familiar with this now, and you'll be getting really good at them. I'm sure you were good at them before, but it's now about linking it. 10.20 nautical miles for C. I'll reveal D in a second. Just give you another minute or so to do all your calculations. And then don't forget, compare it to the calculation before, which was 18.67 nautical miles. Like I said, if you are finished, you could be thinking about how would you work out the bearings that Lifeboat A would need to follow. How would you know, for instance, a bearing is always measured from north in a clockwise direction. Could you be thinking about the bearings if you are finished and you've done what's in purple as well? So let's have a look at the second one. I'm calculating D now, which is this length here. I've already explained why I did the triangle this way round, just because I think it avoids confusion. 2 squared plus 7 squared is equal to D squared. So 4 add 49 is 53. Square root of 53, we get 7.28 nautical miles. And if we add these two together, we're going to get 17.48 nautical miles. And 17.48 nautical miles is over a nautical mile less than 18.67 nautical miles. Now this really could be important. If these ships are relatively slow, this could be a lot of time that's saved in terms of actually rescuing people. 17.48 is less than 18.67. So that calculation there and knowing your maths could potentially save some lives if you was actually sending that lifeboat out to that particular spot. Could we make it any shorter than that? Well, I mean, what are we doing here? These triangles here are actually getting closer to the island. They're getting closer to this island, and maybe that's the way you work out the quickest route is to try to go as close to the island as possible without actually touching the island or without actually touching the ground. So that when we do this in class, you'd investigate this and you'd see how close you could get. Okay, this is another one, slightly different. This time we've brought the helicopter into play. So you're the helicopter dispatcher this time. Okay, but you've just started your shift. So you've taken over from somebody else. Somebody else has already done this calculation. Okay, this is their calculation. And I need you to check this calculation to see if it holds. Okay, so they've done the calculation. And I need you to double check that calculation before you send the helicopter out. Okay, so double check the calculation for me before we send the helicopter out. Is this calculation accurate? Okay, so let's just check this calculation. And was this helicopter dispatcher, did they do the calculation correct, or have they just written something down wrong? Have they made a miscalculation? Well, let's just have a quick look. So 12.5 squared add 7.5 squared. We can see on the diagram here that the vertical and the horizontal meet at a right angle. So there is a right angle there, and we can see that visually. So I'm going to add that on because I can see it. I know it's there. And from there, the only thing that can possibly have gone wrong is a calculation error, but it might be right. So let's just check it out. 12.5 squared add 7.5 squared gives me 212.5. So C squared is equal to 212.5. I'm going to square root both sides. So C is going to equal the square root of 212.5, and that gives me 14.58 nautical miles. So there's been a calculation error here because 14.58 nautical miles is not equal to 15.58 nautical miles. Looks like that may just have been written down wrong. And this does happen in real life. People do just make mistakes, errors. So things do need to be double checked. And the key thing is here, you're under pressure. Time is everything. So calculations have to be done fast and accurate. Fast and accurate. A bit like if you're in an exam almost. And on that note, we're going to have a quick look at a few exam questions now. Alright, so these are exams, standard exam type questions. 2 today that we're going to sort of finish up on. So first one, I'll let you work through it, read it up. Okay, you can see there's the right angle in the corner here, which is what we're looking for. It is distances again, quite large distances, but it's on land, not at sea. So Leicester, York and Norwich. I'm sure you've all heard of those cities. So I'll leave you to calculate this one. It's a 3-mark question. Just remember here, in this question it says correct to the nearest kilometre, so you don't need to do this one to 2 decimal places. You will round to the nearest kilometre. Now just keep that in your mind, because obviously everything else we've been rounding to 2 decimal places all the way through. So just to remind you there, it says nearest kilometre. Okay, let's take a look at this one. Again, it's pretty similar to what we've been doing all the way through today, so I'm sure you found this one quite accessible. So I've labelled my hypotenuse here. I've labelled it as C. So that's York to Norwich in this case. And it says calculate the distance between Norwich and York and give your answer correct to the nearest kilometre. So I know that York to Leicester is 157 squared. And Leicester to Norwich is 168 kilometres, so I've squared that. So I've got 157 squared plus 168 squared equals C squared. I've shown every single line of my working out. And I was chatting to Graham Cumming about this beforehand. And he's saying, obviously, why would you show you working out? You can just punch it in the calculator and write the answer down. Well, of course, if you just make a mistake, a bit like that helicopter dispatcher did, then you won't get any method marks. So you need to show you working out just so that you cover yourself. Basically, if you do make a silly mistake, that you get all the method marks. So that's why I've done it this way, even though you can, probably most of you can do it in a few steps on your calculator. So 24,649 plus 28,224, that comes out to be 52,873. That's what C squared is equal to. And then I square root that 52,873 to give me 229.9412969, and that goes on. And to the nearest kilometre, that's going to be 230 kilometres. So there's my final answer, 230 kilometres, and I'm sure hopefully you all got that. So let's have a look at the next one. Next one is a bit different. Okay, think about the one we did on the helicopter though, checking the calculation. Have a look at this one, and in addition to finding the mistake, if you would like to calculate BC as well, and actually work out what it actually is, that would be good as well. So that I have put that solution in on the next slide. So last couple of minutes if you want to have a go at this one. Okay, so what mistake has Sarah made in her method? It looks to me, I mean, she's got the hypotenuse. She's got the hypotenuse in the wrong place. So she's obviously thinking that the right angle isn't at ABC. So you know, for instance, here, if you know the right angle's here, let me just activate my pen. If you know the right angle is here, then you know that this length here must be the hypotenuse, and that's not how Sarah's set her method out. She says BC squared is the hypotenuse. So she's saying that this length here is the hypotenuse. That's what Sarah's saying. So the mistake is she's misidentified the hypotenuse, and she's misapplied the formula as a result of that. And you can see here I've given my reason, and then I've actually calculated it properly. So it should have been BC squared equals the hypotenuse, which is 8. So it'd be 8 squared, subtract 6 squared, work through to give me BC squared is equal to 64, subtract 36. So BC squared equals 28, and the square root of that would be 5.29 centimetres to 2 decimal places. So I've said the reason why. I've said AC is the hypotenuse, not one of the smaller sides, and that's the mistake that Sarah had made in her method. Okay, as always, we would really welcome your feedback. We are trying to do problem solving, and the next 3 sessions will be around the search and rescue, and they'll get more complicated, and we will try and build on today's one, but obviously keep them as standalone lessons as well, so you can dip in and dip out. So any feedback, please feel free to submit that there, and we'll see you in the next one, which is on Thursday at 11 o'clock. So take care, folks. Enjoy your day. Bye bye.